Some planets exist that, according to our understanding, simply should not. You are invited to discover these bizarre worlds that completely defy our theoretical models, including gas giants cloaked in dust near their parent stars, planets forged from pure carbon like massive diamonds, and even solitary wanderers drifting through the vacuum of interstellar space. Their very existence raises profound questions about how they were formed, and just how much we have yet to learn about the cosmos, pushing the boundaries of what is possible.
Exoplanets are far more than just distant points of light in the night sky. They are extraordinary places that challenge our fundamental assumptions about what constitutes a planet. In our galaxy alone, scientists predict there are thousands of such worlds, each one adding a new and exciting chapter to the annals of astronomy. Their importance cannot be overstated, as by studying them, you not only gain insight into the creation of planetary systems, but also delve into the very real possibility of life beyond our own world.
The quest to find these worlds resembles a cosmic chess match, where every discovery brings us one step closer to knowing if we are truly alone in the universe. Imagine for a moment a planet that is a genuine inferno, where temperatures soar high enough to melt lead. This kind of exoplanet is crucial for helping us define the very limits of habitability, and for making you question what kind of life might endure under such punishing conditions.
Or, picture a world where rivers of lava carve through the landscape and the air is too dense for a human to breathe. These visions might seem like science fiction, but they are potential realities in the immense universe we occupy. The variety among exoplanets is simply breathtaking, with some having such elongated orbits that their seasons are nothing like our own, prompting us to ask how this influences their climate and their capacity to host life. As our exploration deepens, we encounter planets with truly astonishing characteristics. Some may feature oceans not of water, but of molten lava, or even supercritical fluids, forcing you to reconsider what an ocean can be, and what life forms could adapt to such alien seas. It is a thought that ignites the imagination, considering the kinds of organisms that might thrive in these hostile environments. Then there are the diamond planets, where carbon takes on a form far more magnificent than anything known on Earth, offering clues about the fundamental building blocks of planets, and which of those materials could be vital for life.
The discovery of rogue planets, those unbound to any star, serves as a reminder that space is a domain of immense freedom, where entire worlds can wander without a fixed path. These lonely travelers make you ponder their origins, their journey, and their ultimate fate, fueling our drive for further exploration. Additionally, the atmospheres of some exoplanets defy all our expectations, with chemical and physical properties so different from our own that they pose fascinating questions about their formation and stability, and whether life could adapt to these strange conditions.
Among the most intriguing discoveries are the super-Earths, planets larger than our own but smaller than gas giants, which may present conditions suitable for life. The existence of these diverse worlds demonstrates nature's surprising creativity in forming and sustaining life, even in places you might initially dismiss as inhospitable. The intricate dynamics of planetary systems are also captivating, with some featuring multiple planets locked in orbital resonance, performing a cosmic ballet that profoundly affects the geology and climate of each world.
While studying exoplanets, it is also critical to analyze the impact of their star's radiation, as this factor can determine whether a world's atmosphere and surface can support life. This helps us distinguish between potential safe havens and planets that are fundamentally hostile to living organisms. The search for these seemingly impossible worlds is an expedition filled with surprises, employing advanced techniques from transit observations to gravitational microlensing to uncover the universe's diversity.
Ultimately, Exoplanets are more than a fascinating scientific subject. They are a profound reminder that the universe is teeming with wonders and mysteries we are only just beginning to grasp. As you continue on this journey of exploration, each new find brings us closer to the idea that somewhere in the cosmos, life may flourish in ways we can barely conceive. This ongoing adventure is an invitation to dream and to explore what lies beyond. Hot exoplanets, in particular, push the limits of our understanding due to their extreme nature. Consider what it would be like on a planet where the temperature climbs above 1,000 degrees Celsius. In such a place, the climate is not merely warm, but a genuine hellscape. Picture oceans of boiling lava under clouds not of water vapor, but of vaporized metal. This is the reality on WASP 121b, a world offering you a glimpse into a climate that seems torn from the pages of a dystopian novel. On WASP 121b, the temperatures are so severe that any life as we know it would be instantly annihilated. Yet studying this world expands our comprehension of the universe's sheer variety. Can you imagine a typical day there? Instead of a gentle breeze, you would face winds powerful enough to rip trees from the ground, while the rain would consist not of water, but of falling droplets of heavy metals. For all we know, an exoplanet like this could feature a concept of the sky that is utterly alien to our own. The atmospheres of these scorching gas giants present an equally dramatic spectacle. On WASP 121b, for example, it's believed that clouds are formed from vaporized titanium and iron. It is a strange notion. Picture a sky where, instead of soft white clouds, you see ominous, dark formations that move like a procession of metallic tempests. Daily life on this world is a relentless meteorological crisis, with temperatures swinging wildly in mere hours, rendering it a profoundly unstable and hazardous place. But you might wonder why these exoplanets are so crucial in the search for life, especially when their environments appear so hostile. The study of these distant worlds gives us vital clues about how planetary atmospheres are born and how they react to the radiation from their stars. They serve as natural laboratories, allowing us to put our theories of atmospheric chemistry and physics to the test under the most severe conditions. It is truly remarkable to consider that we can learn something fundamental about our own cosmic neighborhood by observing the universe's most extreme locations. While WASP 121b is a standout in its class, other scorching exoplanets also force us to reconsider what is possible in the cosmos. Some of these worlds are so massive they could effortlessly engulf a planet like Jupiter. The gravitational pull on these giants is crushing, and setting foot on one would be an experience unlike anything we could comprehend. Can you even fathom life existing in a place where the sky is illuminated with colors we have never seen, all thanks to the unique chemical reactions happening in its atmosphere? The investigation of hot exoplanets also enables us to understand how stellar radiation shapes these distant worlds. In certain instances, the radiation is so intense that it can dismantle molecules within their atmospheres, making the conditions even more forbidding. This reality prompts a sobering question. What would be the fate of a planet like Earth if it were exposed to such an onslaught? The answer appears to be a definitive and resounding no. There is also a captivating element to the way these planets engage with their parent stars. Their incredibly close orbits mean one hemisphere is perpetually baked by intense light and heat, while the opposite side is locked in a permanent, frigid darkness. This dynamic fosters an astonishing contrast, with temperatures varying immensely across the surface of a single planet. Imagine having to split your existence between a blistering inferno and a deep, icy night, all within the same world. Even the data we gather from our telescopes is mind-boggling. Although we lack the ability to see these worlds directly,
scientists have devised brilliant techniques to deduce their presence and properties. By employing methods like transit observation, we can measure the dimming of a star's light as a planet passes in front of it, which provides clues about its size and makeup. This process is akin to cosmic detective work, where every minute piece of evidence is of the utmost importance. Each new piece of information about hot exoplanets moves us closer to grasping the universe's immense complexity. With every discovery, fresh questions arise. Just how varied can climates be on other planets? Could there be life forms capable of adapting to such punishing environments? While science doesn't yet hold the answers, each exoplanet we identify represents another stride toward deeper understanding. Hot exoplanets serve as a powerful testament to nature's unlimited potential. They compel us to expand our definitions of what is plausible and to envision a cosmos brimming with unexpected wonders. Is it possible that these extreme worlds could be home to life forms that we are currently unable to even imagine? It's conceivable that somewhere in a distant corner of space, organisms are thriving in these seemingly hellish conditions. The allure of these worlds isn't just about their climates. It also extends to their origins. Gaining knowledge about how hot exoplanets are formed and how they mature gives us a valuable look into the grand history of the universe. Every planet offers a narrative about its local conditions and the specific journey it has taken through the vastness of time and space. Ultimately, when you contemplate these distant exoplanets, it is hard not to feel a sense of humility before the sheer scale of the cosmos. Each one is a reminder that our own world is just a single entity among billions. It is human curiosity that propels us to look deeper and to ask what other marvels the universe has yet to show us. Have you ever tried to visualize a planet where magma flows in rivers, and the heat is so intense that any life as we understand it would be instantly annihilated? Today, we are exploring the enthralling realm of lava planets, where blistering surfaces and extreme conditions sculpt a landscape that challenges our very definition of what can exist in the universe. K2-141b is one such world, a place that seems to have been lifted directly from the pages of a science fiction story. This exoplanet, situated roughly 700 light-years from our solar system, experiences a life cycle that is entirely different from our own. On K2-141b, the distinction between day and night is absolute. Picture one hemisphere of the planet in a state of constant exposure to its star, while the other is cast in eternal shadow. This stark division means one side is blanketed in vast oceans of boiling magma, while the other side cools, though its temperatures still remain above 1,000 degrees Celsius. What if I were to tell you that on K2-141b the magma is not static but in a state of perpetual motion and transformation? This concept may sound otherworldly, but it is a direct consequence of the planet's tight orbit around its star. The star's intense heat and radiation cause rock to vaporize into the atmosphere and then precipitate back down on the dark side, creating a continuous cycle of evaporation and condensation that results in a truly surreal environment. This world forces us to consider what kinds of geological phenomena could unfold in such an extreme setting. In a realm of molten lava, water as we know it is an impossibility. Yet, this doesn't mean K2-141b is entirely without elements that could be significant for life. Under certain severe conditions, the chemistry within the magma itself could theoretically foster the development of unknown biological forms. Imagine organisms that evolved to not just survive but thrive in these fiery seas, adapting to searing temperatures and harnessing the magma's thermal energy to power their existence. In such an environment, you can imagine life taking on forms and employing mechanisms that are almost beyond our ability to conceive. This planet is far from unique,
as other worlds with comparable features exist, fundamentally challenging our conventional ideas about habitability. When you contemplate these lava planets, it's natural to question their place within the broader search for life across the universe. Even though K2141b is a profoundly hostile place for us, the incredible diversity of cosmic conditions suggests that life might find a way to emerge even in the most severe settings. Studying the surface of K2141b shows us that its magma not only forges the landscape, but also governs the atmosphere. The chemical exchange between molten rock and water vapor can spawn bizarre atmospheric events, like storms where magma rains down in fiery waterfalls, a spectacle no human eye has ever witnessed. This world serves as a potent reminder that nature has a creative capacity we have only just started to grasp. So, how exactly are these remote planets and their extreme dynamics investigated? Astronomers rely on powerful telescopes and advanced technologies to capture the light these worlds emit. Through a method known as spectroscopic analysis, they can deduce the composition of an atmosphere and surface, providing clues to a planet's true nature and leading us to ask if there are other, undiscovered ways to study these molten worlds. As our exploration continues, you are confronted with a fascinating paradox. If K2-141b and similar lava planets are this extreme, what does that imply for our search for life? Is it conceivable that life forms could exist that defy all our expectations, having adapted to such punishing conditions? The answer might be closer than you imagine, since life on Earth has already proven its astonishing resilience by thriving in the most extreme locations, from deep-sea hydrothermal vents to vast glaciers. Lava planets reveal that the universe is filled with surprises, and each new finding compels a revision of our theories on planetary formation and the possibilities for life. The sheer variety of worlds out there, from the intensely hot to the frigidly cold, is a humbling testament to how much we still have to learn about our own place in the cosmos. Just think what it would be like if we could one day send probes to these exoplanets, gaining real-time imagery and data from these lava worlds that could shatter our understanding of astrobiology. The journey of space exploration is one that is overflowing with potential. Every new piece of information about K2141b and worlds like it opens another door in our mission to understand the universe. In the grand scheme, planets such as K2141b force us to reevaluate what it truly means for a world to be considered habitable. If life could potentially exist in a magma ocean, what other forms might await discovery in the cosmos's darkest corners? The quest for an answer is ongoing, and every exoplanet we identify is a fresh reminder of the boundless unknown. Have you ever heard that some exoplanets follow such eccentric orbits that their climates can undergo radical transformations in just a matter of hours? This is the reality for planets with extremely elliptical paths, a prime example being HD 80606b. You have to imagine a world where a year is completed in only a few days, but those days are so ferocious that temperatures can soar to unbelievable levels. This planet swings so close to its star during part of its orbit that the heat becomes intense enough to melt nearly any material on its surface. When it travels farther away, the temperature plummets dramatically, establishing a climate cycle that seems to be drawn directly from science fiction. The movement of HD 80606b is like a chaotic dance around its star. If you've ever watched a roller coaster ascend and descend with sudden accelerations, you have an idea of how this planet behaves, making its atmosphere almost entirely unpredictable. Imagine a world where day and night are fundamentally different experiences. On HD 80606b, one hemisphere gets so scorching hot it could boil away oceans, while the opposite side stays cooler, perhaps even resembling a winter's day on our own planet. You can't help but wonder what kind of life, if any, could possibly adapt to survive in such an environment. The atmosphere of a planet with such a strange orbit is under constant duress. As it nears its star, atmospheric gases heat up and expand, and as it moves away, they cool and contract. This process can trigger violent storms and drastic changes in atmospheric pressure. Picture a balloon that is being endlessly inflated and deflated. That gives you a sense of what is happening on this alien world. In this kind of setting, a compelling question comes to mind. Could these extreme shifts in temperature and pressure set off unusual chemical reactions? Some scientists theorize that compounds we would never encounter on Earth might form in its atmosphere. This opens the door to the possibility that, while these planets seem inhospitable, they could harbor forms of life completely different from anything we know, expertly adapted to these perpetual changes. If we explore this analysis more deeply, you must also consider what happens to water on such a planet. Here on Earth, water is absolutely essential for life as we understand it. But on a world like HD 80606b, it is possible that water exists in entirely different forms that we can only begin to theorize about. Imagine an entire ocean that could vaporize in a flash, only to condense and fall as rain in a cycle dictated by the planet's journey away from its star. You could witness a world's seas turn to steam and then cool back into storms within mere hours. The intrigue, however, does not end with its climate. The highly unusual orbit of HD 80606b generates gravitational ripples that can disturb the stability of other planets within its system. This cosmic dance means its trajectory doesn't just shape its own environment, but could also have profound consequences for its celestial neighbors, like a game of dominoes playing out on an astronomical scale. The existence of this world leads astronomers to wonder if other planets with such strange orbits are waiting to be found in the vastness of space. This search forces us to completely reevaluate our understanding of how planets form, raising questions about the specific conditions required to create such an eccentric path. With every new discovery like this, our theories about the formation and evolution of planetary systems must expand. As scientific inquiry continues, our technology for detecting these distant exoplanets becomes increasingly sophisticated, allowing us to analyze the light passing through their atmospheres to determine their chemical makeup and unlock future surprises. This entire endeavor is propelled by the fascinating idea that these extreme worlds might be more than just collections of rock and gas. The potential for life, even in forms beyond our current imagination, is what fuels this relentless exploration and curiosity. Reflecting on planets like HD 80606b makes it clear that the universe is far more diverse than we ever conceived. These discoveries are not merely academic exercises. They are powerful reminders that the cosmos is filled with wonders, challenging us to consider possibilities that once seemed purely fictional. Have you ever tried to picture what a planet blanketed in oceans of lava would look like? Envision a world where the heat is so overpowering that the surface never solidifies, but instead flows in fiery rivers. This is the captivating reality of the exoplanet GJ3470b, a place that has seized the attention of scientists and dreamers alike. But to truly grasp its nature, you must consider what it means for a planet to exist in such an extreme state, where molten rock takes the place of water in forming its vast, searing seas. Initially, it's compelling to think about how these oceans of magma come into being. The surface temperatures are so incredibly high that any rocky material liquefies instantly, producing a landscape that would look like a volcano in constant eruption. If you could witness it, you would see a boiling sea of magma, its surface churning and ejecting plumes of vapor. This brings up a seemingly contradictory question. Why is such a world important in the search for life? While lava seems incompatible with biology, some scientists speculate that life could persist even here, much like the extremophiles in our own deep oceans that thrive without sunlight and under immense pressure. The concept of life evolving under such conditions is truly fascinating. While we would find the scorching temperatures and endless lava flows completely inhospitable, Earth has organisms known as thermophiles that flourish in the extreme heat of hot springs and volcanic zones. This suggests life's potential to adapt to similar environments on other planets. The atmosphere on GJ3470b would also be alien, likely composed of dense, lethal gases under pressures far greater than our own. Yet, this very mixture of gas and lava might support life forms with a completely unknown biochemistry, presenting a puzzle that challenges our fundamental understanding of biology. Moreover, the planetary life cycle on a world like GJ3470b would be radically different from our own. Instead of a water cycle, it would have a magma cycle, where molten material rises from the interior, cools into new geological features, and is then melted down again in a continuous, captivating process. Studying such exoplanets reveals just how little we know about the diversity of the universe and the potential for worlds to support life. GJ3470b is a perfect example of how nature can shatter our expectations, reminding us that each discovery is a step toward understanding the cosmos and our place within it. Another intriguing aspect of GJ3470b is its proximity to its star. The exoplanet orbits so closely that it receives an immense amount of energy, which not only creates its extreme temperatures, but also dictates how the surface lava behaves. This closeness could produce climatic conditions totally foreign to us, and you can only imagine how its geology is affected by days and nights that might last just a few hours. Ultimately, the search for planets like this one forces us to redefine our concept of habitability. It makes you question whether liquid water and moderate temperatures are truly necessary for life to exist, or if the answer is far more complex than we ever thought. By investigating worlds with extreme conditions, we broaden the scope of what we believe is possible. Environments we might dismiss as uninhabitable could, in fact, host forms of life beyond our current imagination. Have you ever pictured a world that glitters with the intensity of a diamond? We are about to explore the captivating realm of exoplanets, focusing on one that has stirred the minds of both astronomers and visionaries. A planet designated 55 Cancri E, an extraordinary place where carbon is the dominant element, and whose surface might outshine the most precious gemstones. The exoplanet 55 Cancri E orbits a star much like our own Sun, but this is where the similarities end. Picture a world double the diameter of Earth, yet containing 8 times its mass. These characteristics classify it as a super-Earth, a category of planet that offers insights into the potential nature of other worlds throughout our galaxy. The truly exceptional feature, however, is its high carbon concentration, which has led scientists to theorize it may conceal a core made of solid diamond. The sheer concept of a planet where common rocks and minerals are compressed into diamond is astounding. But what would it be like to stand on such a world? The surface of 55 Cancri E is intensely hot, with temperatures soaring above 1,500 degrees Celsius, a heat so extreme it can easily melt most metals. You could envision a global ocean of lava, with waves formed from the bubbling of boiling magma, which is the stark reality on this planet. Let's turn our attention to the atmosphere of 55 Cancri E, which is drastically different from our own composition of nitrogen and oxygen.
This planet's air is thick with gases like carbon and silicon, creating completely alien conditions. Can you imagine what precipitation would be like there? Instead of water, you might witness showers of carbon crystals falling from the sky. The chemical makeup of this world seems to defy conventional planetary science, forcing us to constantly revise our understanding of how planets are formed. The orbital path of 55 Cancri E keeps it much closer to its parent star than Earth is to the Sun, resulting in a year that lasts a mere 18 hours. How would life feel if every day was a frantic race against the clock? This planet's swift orbit profoundly impacts its climate, generating extreme conditions that are difficult to comprehend from our terrestrial viewpoint, while the intense stellar light bathes its surface in a brilliance we have never witnessed. Considering the formation of this planet raises the question of how such a world could even come into being. The prevailing theory suggests that 55 Cancri E coalesced from the mix of gas and dust within the protoplanetary disk that encircled its star. As this material aggregated, the immense temperatures and pressures acted upon the abundant carbon, crystallizing it into diamond. This incredible process provides us with a deeper appreciation for the sheer diversity of worlds the universe can produce. The prospect of discovering other, similar planets in our galaxy is a thrilling one, as each new find brings us closer to grasping the full spectrum of conditions that might support life, even in its most radical forms. This pushes us to redefine our concept of habitability, suggesting that what we currently deem inhospitable might be a perfectly suitable home for life forms we are not yet equipped to imagine. One of the most captivating questions surrounding 55 Cancri E is its potential to harbor conditions suitable for extreme life, despite being so different from Earth. Our biology is fundamentally water-based, but what if life could arise in a carbon-dominated environment? Is it possible that organisms could evolve to thrive in an existence where intense heat and elemental carbon are the everyday norm? This line of inquiry opens up entirely new possibilities for extraterrestrial biology. Scientists are relentlessly pursuing the study of these bizarre worlds, innovating new technologies and analytical methods to probe their composition and atmospheric features. Each time a new exoplanet like 55 Cancri E is cataloged, it presents a fresh cosmic puzzle to be solved, prompting questions about its hidden secrets and the nature of any life that could have evolved there. Ultimately, our fascination with these distant planets is fueled by a deep-seated human curiosity to comprehend our own place within the cosmos. 55 Cancri E stands as a powerful testament to the universe's capacity for surprise, with every new observation challenging our established ideas about planets and the very nature of life itself. It is far more than just another exoplanet. It is a gateway to a universe of possibilities that encourages us to dream bigger and question everything we assume about the worlds that lie beyond our own. As we forge ahead in our quest for knowledge, every breakthrough takes us one step closer to grasping the vast and enigmatic character of the cosmos. So, the next time you gaze up at the night sky, consider that a planet made of diamond might be waiting out there, filled with wonders we have yet to uncover. Within the grand celestial theater, certain groups of planets appear to move in harmony with a cosmic melody. Imagine a planetary system where each world not only travels its own orbit, but also actively shapes the motion of its neighbors. This remarkable interplay is called orbital resonance, and it is the very phenomenon that makes some exoplanets appear to be dancing. To understand what it means for a planet to be a cosmic dancer, you can think of a group of performers on a stage. While each has their own steps, their combined movements create a mesmerizing, unified performance. Similarly, in space, some planets travel in orbits that are perfectly synchronized, causing their gravitational influences to reinforce one another.
This relationship can be so finely tuned that even a minor disturbance in one planet's orbit can set off a chain reaction throughout the entire system. One of the most spectacular known instances of these dancing exoplanets is the TRAPPIST-1 system. This system is comprised of 7 planets, each roughly the size of Earth, all revolving around an ultra-cool dwarf star. What makes TRAPPIST-1 so extraordinary is not just the number of its planets, but the fact that they orbit in a precise configuration that locks them in a complex chain of orbital resonance with each other. This principle means that for every 2 orbits one planet completes, its neighbor might complete 3 in a precise, repeating pattern. Just consider the mathematical exactness required for such a system to function. It's analogous to a finely crafted Swiss timepiece, but operating on a galactic stage. This phenomenon, known as orbital resonance, is far more than a mere mathematical curiosity, as it carries significant consequences for the long-term stability of these worlds. When planets are locked in resonance, the gravitational tugs they exert on one another can stabilize their orbits for millions or even billions of years. This stability is an absolutely critical factor when you contemplate the potential for life to arise on these planets. For life as we understand it to have a chance to develop, a predictable and steady environment is a fundamental requirement. But you also have to consider the influence of the central star they all orbit. In the TRAPPIST-1 system, the star is significantly cooler than our own sun, which necessitates that its planets huddle much closer to receive adequate light and warmth. This proximity, however, introduces its own set of challenges, as intense stellar radiation could strip away their atmospheres, leading to fascinating questions about their actual habitability and whether they could maintain liquid water on their surfaces. In a tightly packed system like this, the transfer of materials between planets, such as water and other essential compounds, could be more frequent than we initially thought. You can picture a continuous exchange of resources from one world to another, almost as if they were part of an interconnected celestial community. This process might be vital for the emergence of life by ensuring that the necessary building blocks are distributed across multiple planets. Orbital resonance can also trigger some surprising interactions between neighboring worlds. A minor shift in one planet's orbit, for instance, could gravitationally influence the axial tilt of another, leading to incredibly severe seasonal cycles that would dramatically reshape its surface conditions. You have to wonder what kind of ecosystems could possibly adapt and thrive in a world subjected to such extreme environmental swings. To better comprehend how these intricate systems operate, scientists rely on powerful, advanced telescopes. Modern technology allows us not only to confirm the existence of these distant planets, but also to begin analyzing the chemical makeup of their atmospheres. The secrets those atmospheres hold could very well be our first clues to determining the likelihood of life beyond our own world. As we continue to discover more of these dancing exoplanets, it becomes clear that the variety of worlds throughout the universe is far greater than we ever conceived. Each new finding moves us a small step closer to resolving the profound questions about life elsewhere. It forces us to ask if organisms could be thriving in conditions we once believed to be completely inhospitable. This celestial dance of exoplanets is not merely a breathtaking spectacle. It represents a constantly unfolding narrative. Year after year, astronomers uncover new information that challenges our established theories on how planetary systems are born. The synchronized movements of these worlds serve as a powerful reminder that the universe is a profoundly dynamic and ever-evolving place. While our search for exoplanets goes on, it's important to remember that every one of these worlds has its own unique story. Their orbital mechanics and interactions offer valuable insights into how planets form and mature in general, hinting at what else the cosmos may yet show us about life and habitability. So, the next time you gaze up at the night sky, I encourage you to think of these distant, dancing worlds and the immense possibilities they represent. Across the boundless theater of space, a cosmic ballet is in progress, teeming with hidden wonders that are just waiting for us to find them. Among the most captivating of these mysteries are the rogue planets. Unlike the worlds we know that are tethered to stars, these planets drift in solitude through the immense void. Imagine a sprawling, vibrant city suddenly having one of its districts lose all power, plunged into a directionless, perpetual darkness. This is the reality for a rogue planet, lost in space without a sun to offer it any warmth or light. The most immediate question is how such lonely worlds come to be. While several theories exist, the most widely accepted one suggests they are born within conventional planetary systems, but are eventually ejected by powerful gravitational forces. This expulsion can occur due to close encounters with other massive planets, or passing stars that disrupt their orbits. It's almost like a game of cosmic billiards where one planet is struck and sent careening away from its stellar family, destined for a solitary journey through the interstellar dark. So, how can we possibly know these wandering planets even exist? Despite being unlit by any star, astronomers have developed brilliant methods to spot them. The primary technique is called gravitational microlensing, which functions somewhat like a cosmic magnifying glass. When a rogue planet drifts in front of a distant star from our perspective, its gravity bends and focuses the starlight, causing a brief, detectable spike in the star's brightness. It's a fleeting moment where the invisible suddenly makes its presence known. Picture the astonishment among scientists upon realizing that our galaxy might host more of these nomadic planets than it does stars, suggesting the number of these lonely worlds could be truly staggering. Life on such an isolated planet would be subjected to conditions radically different from those in a solar system. Without a sun, surface temperatures on a rogue planet would plummet to unimaginably cold levels, seemingly rendering it completely inhospitable to life as we know it. And yet, the lack of sunlight doesn't automatically rule out the possibility of life. Some scientists propose that life forms could exist that are not dependent on solar energy at all. It's conceivable that organisms could draw power from geothermal heat bleeding from the planet's core, or from chemical reactions occurring deep beneath the surface. This is a truly thrilling idea, the notion that life could find a way to prosper in environments we never thought possible. But what might the surface of a rogue planet actually look like? You can imagine a vast, frozen wasteland under a sky of absolute black, where relentless winds howl across landscapes that are perpetually dark. Unlit by any star, the surface of such a world could be a deep layer of ice or bare rock that has never once been touched by the warmth or light of a sun. Imagine an environment seemingly pulled from science fiction, where temperatures plunge so low that water flash freezes on contact. What's even more fascinating is the idea that some of these solitary planets may not be entirely alone. They might possess their own orbiting moons. These companions could have their own distinct qualities and, just perhaps, could even support some form of life. A tiny satellite circling a colossal frozen world, sharing its profound isolation. As our exploration of the cosmos expands, the quest for these rogue planets becomes an increasingly compelling mission. It sparks the question of whether entire systems of wandering worlds might exist, cultivating their own unique ecosystems in the void of space. The prospect that these planets are far more numerous than we ever conceived is a thrilling one that fuels our drive for cosmic discovery. One of the most stunning findings is that certain rogue planets seem to possess atmospheres. This immediately begs the question, how could they possibly hold on to an atmosphere so far from any star? The solution might be found in their own internal heat, which could generate enough energy to trap specific gases at their surface, much like a volcano venting steam to create an atmosphere on an otherwise desolate world. Every new discovery of a rogue planet confronts us with more profound questions about our universe. Just how prevalent are these lonely travelers? Is it possible they contribute to the birth of new stars or planetary systems? Science is actively working to unravel these mysteries, and with each new piece of data, we move a step closer to grasping the true complexity of the cosmos. When you reflect on these wandering worlds, it's crucial to see them as an unsolved piece of the universal puzzle. They reveal the sheer diversity of worlds that can exist, including those that seem utterly impossible. Each of these solitary planets serves as a powerful reminder that the universe is a place brimming with surprises and secrets, just waiting for us to find them. So, rogue planets are a profound confirmation of the cosmos's incredible variety, urging us to venture beyond the familiar and envision what might lurk in the interstellar darkness. But what if I told you that even within solar systems, there are worlds with atmospheres so bizarre they challenge all reason? Consider exoplanets like HD 209458b, which boasts features so astounding they feel like fiction, with an atmosphere so intense in temperature and pressure that it acts more like a furnace than a home. The immediate question is, what exactly makes these atmospheres so extraordinary? In the case of HD 209458b, analysis has revealed not only water vapor and clouds of condensation, but also elements you would never expect on Earth. The combination of these components results in an extreme setting where life as we understand it could never take hold. But what if that doesn't rule out the existence of another kind of life entirely? Scientists are actively investigating the potential for life to adapt to such punishing conditions. Picture organisms that have no need for oxygen or liquid water, instead flourishing in a dense, scorching, gaseous medium. On our own planet, certain microorganisms are already capable of surviving in hostile places, such as the hydrothermal vents on the ocean floor. It's possible that on other worlds life has evolved in ways we can scarcely comprehend. Now let's consider the heat. On HD 209458b, the temperatures soar high enough to liquefy metals, which has a dramatic effect on its atmosphere. The intense heat causes gas molecules to behave very differently than they do here, similar to how boiling water produces highly energized steam. Consequently, this planet's atmosphere is in a state of perpetual chaos, a vortex of complex chemical and physical reactions. When discussing these strange atmospheres, we must also address the immense pressure. On HD 209458b, the atmospheric pressure is many times greater than what we experience on our own planet. You can imagine the sensation of being deep in the ocean, where the weight of the water above you intensifies as you descend. On this exoplanet, such crushing pressure could fundamentally transform the chemistry of gases, leading to conditions almost beyond our imagination. Moreover, the chemical makeup of its atmosphere is captivating. Researchers have identified carbon and other elements essential for life. But what if they combine in wholly unfamiliar ways? Instead of assembling into the biological structures we recognize, they could be forming entirely new compounds, never before seen on Earth. This possibility opens a path to life forms built on a completely different chemical foundation. The study of these alien atmospheres not only deepens our understanding of exoplanets, but also provides vital clues about how planets form and evolve across the universe. Each new finding is like adding a piece to a grand cosmic puzzle, bringing us closer to a complete picture. This process also highlights the crucial role of stellar radiation, as the stars these planets orbit can unleash energy that alters atmospheric composition, sometimes even stripping away the lighter layers.
Finally, it's fascinating to ask how these exotic worlds measure up against our own. Here on Earth, our atmosphere maintains a delicate equilibrium of oxygen, nitrogen, and other gases that allows life to flourish. This precise balance enables us to breathe and thrive. However, on planets like HD 209458b, such a delicate equilibrium is entirely absent, showcasing a vastly different and more hostile model of a world. It is quite possible that the forms of life familiar to you are not the only ones that the universe has to offer. The ongoing search for exoplanets with unusual atmospheres compels you to contemplate your own existence and question just how unique we truly are in the grand cosmic expanse. The sheer variety of atmospheres we are discovering hints that life could be far more diverse than previously conceived, with entirely different ecosystems flourishing in environments that you would likely deem uninhabitable. Furthermore, the technologies we employ to investigate these distant planets are advancing at an astonishing rate. With the advent of more powerful telescopes and novel observation methods, our capacity to detect and analyze these atmospheres is constantly expanding. Each new finding brings you one step closer to resolving the fundamental questions that have intrigued humanity for millennia. Consequently, exoplanets with peculiar atmospheres, such as HD 209458b, act as a powerful reminder that the universe is teeming with surprises. Every world you explore challenges you to think beyond established knowledge and to entertain the possibility that life exists in forms you could never have predicted. This pursuit not only deepens your comprehension of the cosmos, but also encourages a profound reflection on your own existence and place within it. So, the next time you cast your gaze upon the night sky, remember that there are worlds out there that are radically different from ours, and it is entirely possible that they possess their own unique stories to share about the nature of life itself. A fascinating class of exoplanets known as super-Earths has captured the imagination of both astronomers and space enthusiasts because of their unusual dimensions and features. Their distinction lies in being larger than Earth, yet smaller than gas giants like Jupiter and Saturn, making them an exciting puzzle in the search for potentially life-bearing worlds. To give you a sense of scale, while our planet has a diameter of approximately 12,700 kilometers, super-Earths can range from slightly larger to more than double that size. This immediately raises the compelling question of what sort of conditions might prevail on these planets. A particularly interesting aspect of super-Earths is their gravity. Being more massive than our world, they exert a much stronger gravitational pull, which would profoundly influence everything on their surface. Imagine yourself standing on a super-Earth, where every step would feel entirely different. You certainly couldn't leap as high as you can here, as the intensified gravity would make movement a completely new kind of challenge. This additional gravitational force also has a major impact on how their atmospheres form, potentially creating a denser envelope that is crucial for retaining heat, a key ingredient for life. Regarding those atmospheres, scientists speculate that they might consist of a mixture of rock and gas, similar to gas giants, but with characteristics that could allow liquid water to exist on the surface. You can picture it as a kind of cosmic pressure cooker, where extreme heat and pressure create conditions you would not encounter on Earth. The diversity offered by these super-Earths is truly astonishing, especially when you learn that some might harbor not just oceans of water, but also vast seas of molten lava.
Prominent examples such as LHS 1140b and K2-18b stir your curiosity about the possibility of life, making you wonder if they could host organisms adapted to such extreme conditions. Although most super-Earths found to date are many light-years away, studying them is crucial for understanding how planets form and evolve throughout the universe. Every new discovery adds another piece to the vast cosmic puzzle. An often underappreciated factor is the influence of the star that these super-Earths orbit. A planet's distance from its star is the primary determinant of its temperature, and, by extension, its capacity to sustain liquid water. If a super-Earth were too close, it would face scorching temperatures, rendering life as you know it impossible. Conversely, a planet positioned too far away would become a frozen, icy world, which underscores just how critical precise orbital placement is. Then there is the matter of geological diversity on these worlds. The greater gravity could lead to the formation of mountains far taller than our own, or oceans of unimaginable depth. The geological features of these planets could be fundamentally different from Earth's, potentially giving rise to entirely distinct climates and ecosystems. This prompts another question. Could there be life forms adapted to these severe conditions, much as some organisms thrive in the most hostile environments on our own planet? The search for super-Earths also leads you to consider the potential for human colonization in the distant future. If humanity ever embarks on an interstellar journey to settle other worlds, these planets could be compelling candidates. However, you must acknowledge that travel across such vast distances in space is immensely complex and expensive. You have to ask what kind of technology would be necessary to reach these remote worlds, and, more importantly, whether we could survive in such a radically different environment. There are also theories suggesting that super-Earths could feature incredibly diverse climatic conditions. Some might undergo extreme seasonal changes, while others could enjoy more temperate and stable weather patterns. You can imagine a planet where temperatures fluctuate dramatically between day and night, or one where the climate remains nearly perfect all year round. This climatic variability would make each super-Earth a truly singular place in the cosmos. Research into super-Earths has demonstrated that they are not merely larger versions of our home world. Instead, they are unique planets, each with its own set of mysteries, complexities, and possibilities. As scientists persist in their search and analysis of these bodies, every discovery may force you to rethink your entire understanding of habitability and the potential for life in the universe. The fascination with super-Earths isn't just about their size or composition. It also invites you to reflect on your own existence. As you ponder these faraway worlds, you inevitably ask yourself what it means to be human in such an expansive and diverse cosmos. Each super-Earth you discover serves as a potent reminder of how little we truly know, and how much more there is still left to learn. With every technological leap, our telescopes grow more potent, transforming the hunt for super-Earths from a distant dream into an attainable objective. The secrets held by these worlds, which spin silently in the cosmic darkness, might be uncovered sooner than you imagine. Each new mission into space propels us closer to grasping our own significance in the universe, making the exploration of super-Earths not merely a scientific pursuit, but a profound search for meaning that invites us to dream and venture into the unknown. In the boundless cosmic ocean, these planets serve as beacons of possibility, suggesting that life in its myriad forms could be far more prevalent than we ever dared to believe. Across the vastness of the universe, a captivating phenomenon exists that truly tests our comprehension. Exoplanets residing in binary star systems. This means that instead of a single star, a pair of suns might be locked in a cosmic dance, with planets orbiting them in a celestial display that is both visually stunning and scientifically perplexing. Such a configuration raises fascinating questions about the very nature of these worlds and their capacity to support life, challenging our conventional understanding of planetary systems.
One of the most compelling aspects of exoplanets and binary systems is the profound influence that two stars have on their environment. Can you picture what it might be like to exist on a world where two suns illuminate the sky? The intensity of light and ambient temperature on such planets can be radically different from those orbiting a solitary star. For example, seasons could be far more extreme or, conversely, surprisingly mild, all depending on the planet's axial tilt and its orbital path around the twin stars. The famed exoplanet Kepler-16b, which orbits two stars, serves as a prime example, suggesting a climate utterly alien to our own.
Imagine a sky where you could witness sunrise and sunset occurring in two separate locations simultaneously, a concept that defies our everyday logic, but becomes a physical reality on these distant worlds. The complex interplay between the two stars could generate unique weather patterns and temperature fluctuations unseen within our own solar system. Furthermore, the geology of these planets is likely shaped by the intricate gravitational forces at play. This dual pull could amplify tectonic activity, sculpting mountains, valleys, and oceans into configurations we can scarcely envision, and perhaps even triggering more frequent earthquakes or volcanic eruptions under the light of two suns. The prospect of finding water on these worlds is another thrilling area of inquiry. How would oceans behave when warmed by two separate stars? The additional energy could potentially maintain water in its liquid state across a wider range of orbital distances, thereby expanding the potential for life to emerge in unexpected places. In some cases, the increased radiation might even help forge complex chemical compounds within the atmosphere, which are crucial precursors for life. It is entirely plausible that these worlds harbor beings that have evolved under conditions completely dissimilar to our own. However, the conditions within these binary systems are not always favorable. The intricate dance of the stars can also foster incredibly hostile environments. For instance, the combined stellar radiation from two sources could be so intense that it would make it exceedingly difficult for life as we know it to gain a foothold. The planetary conditions might be wildly unstable, leading to devastating storms or abrupt, extreme shifts in temperature. This reality forces us to ask whether every exoplanet in a binary system is inevitably destined to be an uninhabitable wasteland. Yet, our search for life on these distant worlds should not be confined to finding Earth-like atmospheres or liquid water. The sheer diversity of conditions in binary star systems might give rise to forms of life that we cannot currently imagine. What if there are organisms that have evolved to thrive amidst intense radiation, or to endure dramatic temperature swings? Life on such planets might more closely resemble extremophiles found in volcanic vents on Earth, whose survival hinges on an ability to withstand the most severe conditions imaginable. Investigating binary systems also presents new challenges regarding our theories of planetary formation. How do planets even coalesce in an environment dominated by the gravitational pull of two stars? Answering this could greatly enhance our understanding of the variety of planets found throughout our galaxy. While some scientists theorize that the initial formation process is similar to that in single-star systems, the subsequent gravitational interactions could steer their development in ways we are only just beginning to comprehend. The transit method, our primary tool for detecting exoplanets by observing the dimming of starlight, becomes significantly more complex in these systems, making it a challenge to confirm that we are observing a planet and not a cosmic illusion created by the stars themselves. The true wonder of exoplanets and binary systems is their power to reveal the vast, unexplored frontiers of the universe. Every discovery serves as a humbling reminder of our small place within the cosmic expanse and compels us to reconsider the fundamental possibilities of life itself. As we continue to explore these remote worlds, we are not just expanding our knowledge of planet formation. We are fueling our innate curiosity about what mysteries lie waiting in the depths of space. So, when you next gaze up at the starry sky, take a moment to contemplate this cosmic ballet of stars and their orbiting planets, and the incredible secrets they may hold. Every binary star system and each new exoplanet prompts you to ponder the limitless possibilities that lie beyond our world. In this immense cosmos, variety is the standard, making the pursuit of knowledge a boundless adventure. The sheer diversity of these distant worlds is continually astonishing, and among the many we found, some are subject to the most severe seasonal shifts. Imagine having to live on a planet where the seasons undergo such radical transformations that you must constantly adjust to a climate full of unpredictable changes. This is the reality for certain exoplanets found at our galaxy's edge. Worlds with extreme seasons are characterized by monumental climatic shifts as they travel along their orbital paths. Unlike Earth, where our seasons follow a relatively predictable pattern, picture a planet where temperatures can swing wildly, resembling something from a science fiction tale. Consider what it would be like if a single year on such a world spanned the equivalent of several of our decades, a phenomenon observed on some of these very celestial bodies. A key factor driving these dramatic changes is their axial tilt. On Earth, our stable seasons are a result of the 23-degree axial tilt, but some exoplanets are tilted at a much more severe angle. This extreme inclination can lead to a situation where one hemisphere bakes under intense prolonged heat, while the opposite hemisphere is locked in a deep, icy freeze. It creates a stark dichotomy, as if one side of the planet is trapped in a permanent summer, while the other endures an unending winter. You have to wonder what kind of life could possibly arise and survive in such a divided environment. In a place where the climate shifts so drastically, any life forms would need to be master survivors. Picture creatures capable of rapidly adapting to the blistering heat of a perpetual summer, or the frigid darkness of an endless winter night. Under such volatile conditions, evolution could give rise to astonishing organisms with traits that currently defy our imagination. The atmospheric dynamics of these planets also play a crucial role in their extreme nature. On a world with severe seasons, the very makeup of the atmosphere can alter dramatically from one season to the next. In the summer, you might see a buildup of hot gases, whereas winter could bring a significant decrease, triggering unique meteorological events. Can you even conceive of the storms that might rage in a place where the temperature can plummet or soar in a matter of days? On some exoplanets, particularly those orbiting cooler stars, the seasons themselves can extend for many years. On such a planet, experiencing a complete seasonal cycle would unfold over a timescale that would feel almost infinite to us. Life there would likely have to adapt to these incredibly long periods, establishing a biological rhythm completely alien to anything we are familiar with. These severe conditions would also leave their mark on the planet's geology. Intense climatic fluctuations could amplify geological processes like erosion and volcanic activity, creating a world in constant flux. When one hemisphere is subject to extreme heat and the other to deep cold, you can expect to see rapidly shifting landscapes, as if the planet's surface is perpetually reshaping itself. The question of what kinds of geological features might emerge from such an unstable climate is truly fascinating. Yet, our curiosity extends beyond just the climate, as the interaction between these worlds and their parent stars is equally compelling. For instance, some exoplanets follow elliptical orbits that cause them to swing much closer to and then farther from their star, a cosmic dance that can greatly intensify their seasonal shifts. For astronomers,
The study of these unique exoplanets is vital because it provides a window into the intricacies of planetary formation and the sheer diversity of conditions the universe can produce. By observing these distant worlds, we can gain a deeper understanding of how planetary systems evolve and how extreme environments might shape the course of life. This research also forces us to ask profound questions about the potential for life elsewhere. While these environments may seem inhospitable to life as we understand it, they might just be the cradle for highly adaptive organisms that thrive in what we would consider impossible conditions. Life has consistently demonstrated an incredible capacity for adaptation, and these planets could serve as the ultimate testament to that resilience. Each discovery of an exoplanet with extreme seasons is a powerful reminder that the cosmos is full of surprises, and that nature frequently challenges our preconceived notions. Each new finding underscores how much we still have to learn, not only about the universe, but also about our own place within it. The exploration of exoplanets is an exhilarating journey that has only just begun, with every world telling its own unique story that fuels our curiosity and imagination. As we continue this stellar voyage, it's essential that you keep an open mind, because nobody knows what other mysteries the universe holds in store. With every fresh discovery, we broaden our comprehension of what it truly means to be a part of this vast cosmos. Within this immense universe, where enigmas are as plentiful as stars, there's a particular phenomenon that captures the interest of both scientists and dreamers: the impact of stellar radiation on exoplanets. But what exactly does this entail? Think of every star as a colossal beacon emitting light and energy that radiates through the void. This energy can be so immense that it influences surrounding planets in remarkable, and sometimes severe, ways, fundamentally shaping their nature. When we speak of stellar radiation, we are referring to the flow of energy that stars release as light, heat, and charged particles. This emission is far more than just a source of illumination. It can be the single most critical factor determining a planet's potential for habitability. For example, this radiation has the power to superheat an exoplanet's atmosphere, which can completely transform its climate into something unrecognizable and profoundly different from its original state. Stellar radiation can certainly be seen as a cosmic force that dictates whether a planet's climate is temperate and life-sustaining or dangerously hot. Take the captivating case of HD 189733b, an exoplanet situated a mere 63 light-years away from Earth. It is renowned for its remarkably thick atmosphere and severe weather, where the star's intense energy leads to downpours of molten glass, a truly incredible concept where shimmering shards fall from the sky instead of water. The influence of stellar radiation extends beyond the atmosphere, deeply affecting a planet's surface as well. On the exoplanet known as 55 Cancri E, for instance, the surface is so intensely heated that it resembles a raging inferno. This reality compels us to ask what forms of life could possibly endure such punishing conditions, leading to the complex and fascinating idea that life there might be fundamentally different from anything we recognize, perfectly adapted to an environment of perpetual radiation and heat. The distance of a planet from its star is another pivotal factor in this equation. Worlds that orbit in very close proximity, such as WASP-12b, are bathed in a far greater intensity of radiation, resulting in a dramatically different climate. Conversely, planets at a greater distance might enjoy a more moderate environment, but this alone may not be sufficient for life to emerge. The final answer could very well hinge on additional variables, like the specific chemical makeup of their atmospheres. For a moment, picture yourself standing on a remote world, beneath an alien sky, lit by the glow of a distant star.
The kind of radiation this planet receives might be so unlike Earth's that any life, should it exist, would have evolved completely novel ways to thrive in its surroundings. It's truly compelling to contemplate the sheer diversity of life that could flourish under such different cosmic circumstances, perhaps even leading to unique atmospheric events as radiation breaks down molecules in ways we've never observed. As astronomers investigate these exoplanets and their atmospheres, they are truly navigating uncharted territory. They employ sophisticated telescopes to analyze the light that filters through these alien skies, scrutinizing their composition for any hints about how stellar radiation shapes every last detail. This meticulous work is much like a detective piecing together evidence at a crime scene, where each new finding has the potential to fundamentally alter our view of the cosmos. Examining stellar radiation also provides invaluable lessons about the formation of planets and solar systems. It helps us probe the question of why some worlds develop into barren, lifeless spheres, while others become lush, water-filled paradises. The answer may be found in the way their stars' energy guided their evolution over countless millennia, which in turn leads us to consider how a planet's environment can mold its entire history and ultimate destiny. With every technological leap, scientists are uncovering new worlds and accumulating data on a scale that was once the stuff of dreams. Each newly spotted exoplanet draws us nearer to comprehending the staggering variety within our universe. We can only wonder what other truths stellar radiation will unveil in the years ahead, as its influence serves as a potent reminder that the cosmos is brimming with surprises that challenge our imagination and force us to consider life existing in defiance of our current understanding. In essence, stellar radiation is a central character in the cosmic drama of exoplanets, driving everything from the creation of extreme climates to the possibility of life in the most unusual settings. Its impact is both profound and multifaceted, with each discovery inviting us to explore deeper and to reconsider what we know about life, climate, and planetary development in the immense universe around us. As we press on in our quest, human curiosity remains the essential engine propelling us forward to unlock the secrets of the cosmos. Icy exoplanets represent worlds that truly test the limits of our imagination, forcing us to envision places so profoundly cold that their temperatures plummet to levels we can barely comprehend. The fascination with exploring these frozen realms stems from a simple reason. They allow us to understand the universe's extremes and to speculate on how life might survive in conditions that would be utterly lethal to us here on Earth. Consider, for example, the exoplanet designated OGLE 2005 BLG 390LB. This world, positioned thousands of light-years from our solar system, resides in a region so cold that most of us could not endure it for a single moment. To grasp what it means to be in such a frigid place, think of a winter night when the temperature falls below freezing, and then imagine that chill magnified to a permanent, year-round state. This is a world where water would be frozen into its most solid form, and any potential life would need to be adapted to these unforgiving conditions. The very makeup of OGLE 2005 BLG 390LB remains an enigma. Being so distant from its parent star, its temperatures are comparable to those inside a deep freezer. But what does that imply for its surface? One can imagine an atmosphere composed of a mixture of frozen gases, where elements like oxygen and nitrogen would behave in ways entirely alien to our experience. Instead of breathable air, one might find a dense, cold atmosphere that would feel like being immersed in a sea of icy vapor. This inevitably raises the question of whether life could possibly take hold in such a place. Here on Earth, we have discovered microorganisms thriving in the most extreme locations, including the glaciers of Antarctica. This knowledge encourages us to believe that if any life exists on a frozen planet like OGLE 2005 BLG 390LB, it would likely be organisms that have evolved extraordinary adaptations to survive within the ice itself. Perhaps we would encounter beings that derive their energy from chemical compounds rather than sunlight, fueling themselves through chemical reactions in the perpetual cold.
Many of these distant worlds are encased in immense shells of ice, suggesting the profound possibility of liquid water oceans hidden beneath their frozen surfaces. This concept mirrors what scientists suspect about Europa, one of Jupiter's moons, which is thought to harbor a vast ocean under its icy crust. It's a tantalizing thought that beneath the frozen exteriors of these exoplanets, entire ecosystems could be flourishing with life forms we have yet to encounter. The climate on these icy worlds presents an equally captivating subject for speculation. You can imagine an exoplanet besieged by winds of frozen particles moving at incredible velocities, giving rise to blizzards that might rage for days or even weeks on end. This paints a picture of a landscape where these winds sculpt ice crystals into structures that glitter like a field of diamonds, creating a truly spectacular vision of reflected light against the absolute black of space. Contemplating the potential for life on these frigid worlds also brings up another fascinating question. How would such organisms communicate with one another? In a realm where severe cold is the constant reality, it's very likely that any native creatures would employ methods of communication entirely different from our own. They might use vibrations sent through the solid ice, or perhaps utilize bioluminescence, generating a silent, luminous ballet in the perpetual twilight. The very existence of these exoplanets compels us to rethink our theories on the formation of planetary systems. It seems the distribution of stars and planets throughout the cosmos has permitted these ice-covered worlds to arise in regions where we previously might not have considered life possible. The sheer variety of conditions these planets exhibit serves as a powerful reminder that the universe is far more intricate and surprising than we can currently comprehend. So, what part do these icy exoplanets play in our ongoing quest for other habitable worlds? By investigating these planets, we gather crucial data about the formation and evolutionary paths of celestial bodies. They could be the key to helping us pinpoint the essential conditions for life to flourish in other parts of the universe, including in environments that appear hostile and unwelcoming at first glance. Moreover, the study of icy exoplanets provides us with valuable insights into the potential future of our own world. When we understand how these planets react under extreme environmental pressures, we can refine our predictions about Earth's own climate and the trajectory of its future changes. This knowledge may prove indispensable in our efforts to confront challenges like climate change and the preservation of our environment. Ultimately, as we continue to identify these frozen exoplanets and probe their secrets, the greatest question of all still looms. What other wonders are waiting for us in the immense expanse of the cosmos? Each new finding inches us closer to an answer, revealing that even in the most frigid and remote locations, the potential for life and discovery persists. This search is more than just an exploration of space. It is a quest to understand our own place within this vast universe. But what if a planet is orbited by more than one moon? Here in our solar system, Earth possesses a single moon that governs our tides and influences our planet's cycles. Imagine, however, what existence would be like on an exoplanet with a whole system of moons, where each one could have a vital impact on the planet's geology, climate, and overall potential for life. Visualizing an exoplanet with multiple moons is like picturing a grand celestial ballet, with each moon following its own distinct rhythm and exerting its unique influence.
Regardless of their size, the collective presence of these moons can dramatically reshape conditions on the parent planet. For instance, did you know that their combined gravity could generate colossal tides, powerfully sculpting both the world's surface and its atmosphere, and potentially driving a cycle of life completely alien to us? Take the case of Kepler 1625b, an exoplanet that has captured the imagination of astronomers because of its intriguing lunar system. This distant world not only orbits a star, but also seems to possess at least one moon of considerable size. Just think about how the gravitational force of such a massive moon could dictate the climate of Kepler 1625b. Its pull might create tides so powerful they constantly remold the planet's surface, resulting in a perpetually dynamic and evolving world. What if I were to tell you that moons themselves could foster life? In certain scenarios, a large moon can stabilize its planet's axial tilt, which in turn leads to a more predictable and temperate climate with regular seasons. This stability could provide the ideal circumstances for life to emerge. In a system with several moons, the complex gravitational interplay could forge an environment where life evolves in entirely new and unexpected directions. A crucial question then becomes how these moons might affect an exoplanet's atmosphere. Moons can be instrumental in preserving a more stable atmosphere, effectively shielding the planet from the unforgiving conditions of outer space. Much like how Earth's moon helps protect us from meteorite strikes, an exoplanet's moons could serve to buffer it against stellar radiation and other cosmic dangers. However, the situation is not always so advantageous, as moons can also be agents of immense destruction. Picture an exoplanet where the moons align in just the right way for their gravitational forces to compound. Such an event could unleash cataclysmic tides, trigger tsunamis of molten rock, or cause sudden violent shifts in the planet's atmosphere. A system of multiple moons has the potential to produce an incredibly chaotic climate, where conditions can change drastically from one day to the next. Returning to Kepler 1625b, the gravitational dance between the planet and its moon could lead to truly unique atmospheric phenomena. What if the moon induced a bizarre seasonal effect, creating extreme cycles of intense heat and freezing cold? This would be a world with erratic seasons, demanding that any life there be in a constant state of adaptation. Furthermore, the gravity from multiple moons could profoundly influence an exoplanet's geology, triggering widespread volcanic or tectonic activity, and forging landscapes in ways we can scarcely begin to imagine. This gravitational influence could result in the formation of mountains, deep valleys, and even vast oceans of molten lava. Such geological activity might forge an environment where life could gain a foothold, carving out a niche for itself even under the most forbidding conditions. A truly captivating idea surrounding exoplanets with satellites is that the moons themselves could be habitable. If a moon possesses the right conditions, it might support ecosystems completely distinct from those on its host planet, essentially forming a miniature solar system where each moon is a unique world with its own climate, features, and potential for life. Just imagine the sheer variety that could manifest within a system containing several moons. Every single one could possess its own unique geology, atmosphere, and set of climatic patterns. This incredible variability could provide fertile ground for the evolution of life in forms entirely unlike anything we are familiar with. It's impossible to know what kinds of marvels might be waiting on the moons of a distant exoplanet, each one a separate experiment in biology. When you reflect on the impact of moons on exoplanets, it becomes crucial to see how these interactions could reshape our entire concept of habitability. Life might emerge in circumstances that appear completely unlivable at first glance,
all because of the presence of one or more moons that stabilize or transform the planetary environment. Ultimately, studying exoplanets with multiple moons unveils a universe of possibilities for how and where life might arise in the cosmos. Each new finding brings us a step closer to grasping the intricate nature of these systems and the incredible diversity of worlds that exist beyond our own. Somewhere in a distant corner of the universe, a planet with numerous moons could be engaged in a perfect celestial dance, creating an environment where life flourishes in ways we can't yet even conceive. So, the next time you gaze up at the night sky, remember that there are far-off worlds with their own moons and secrets, all waiting to be discovered. Throughout the vastness of the cosmos, there are worlds that defy our very notions of stability and permanence. Try to envision a planet where atmospheric conditions shift so dramatically that you could witness all 4 seasons in the span of a single day. This is the reality for exoplanets with unstable atmospheres, worlds that seem torn from the pages of science fiction, yet are very real discoveries in the depths of space. One such world is WASP-76b, a gas giant that orbits a star within the Pisces constellation. What makes this particular world so staggering isn't merely its size or its location, but the thoroughly chaotic character of its atmosphere. The reason a planet can experience such a wildly fluctuating climate is the intense radiation it absorbs from its parent star. Its proximity causes its atmosphere to heat to extreme temperatures, which in turn creates conditions that can completely change within a matter of hours. On WASP-76b, a place where temperatures can shift so radically in such a short period, this is the norm. The atmospheric currents on this planet are so forceful they can transport clouds of sodium vapor, which then results in rainfall of liquid metal. While this may sound like something from a movie, it is a genuine manifestation of the extreme conditions that can exist throughout the universe. The climate on this world is a truly spectacular, if terrifying, sight. The storms that rage there are so intense that they could dwarf any hurricane known on Earth, as clouds of gas materialize and vanish in moments, triggering abrupt and severe changes in temperature and atmospheric pressure. Life as we understand it would stand no chance of surviving in such a volatile environment. But what about more extreme forms of life? Is it possible that something could adapt to these constant, violent changes? Science reminds us that in the search for life on other worlds, we must keep an open mind to all possibilities. Considering we have found organisms on Earth capable of surviving in extreme places, like the crushing depths of the ocean floor or the frigid expanses of Antarctica, could something similar exist on a planet like WASP-76b? The idea that life could evolve to thrive in such hostile settings might not be so far-fetched. Unstable atmospheres are not an isolated occurrence. Other exoplanets exhibit similar traits, with some experiencing atmospheric changes driven by interactions with their stars. This can profoundly affect their chemical composition, as extreme temperatures and intense radiation alter the chemistry of the gases, producing unique phenomena like brilliant auroras and cloud patterns we have never witnessed before. As our technology continues to advance, we will be able to observe and analyze these fascinating worlds in much greater detail. Every new discovery promises to offer answers to questions we have not yet even thought to ask. It is incredible to think that beyond our own world, something so exciting and simultaneously terrifying exists. And each new piece of information brings us closer to understanding our true place in the cosmos. What if I told you that some of the most fascinating and extreme exoplanets we've found could be harboring life forms completely alien to us? The quest for life beyond our solar system has prompted scientists to consider even the most inhospitable worlds as potential habitats. But how could this be possible? What features of these supposedly impossible exoplanets might actually generate conditions favorable for life?
To start, let's consider the sheer diversity of life right here on Earth.
From organisms thriving at the bottom of the ocean to those that endure radiation in the desert, life demonstrates an extraordinary capacity for adaptation. Now, I want you to picture an exoplanet so scorching it resembles a vision of hell, a place with a climate so severe that most life forms we know would be instantly annihilated. Yet, what if organisms have not only adjusted to these conditions, but are flourishing in ways that defy our imagination? Consider a world like WASP-121b, where temperatures soar to unbelievable heights. It's plausible that scientists could uncover life forms there that harness extreme heat as an energy source. Much like the microorganisms on Earth that cluster around thermal vents, these fiery worlds might host creatures that metabolize the thermal energy of their own environment. It's a remarkable thought, that life could find a foothold in a climate so fundamentally inhospitable. When you think about lava planets, such as K2141b, you might envision a surface roiling with molten magma. Despite this, some researchers propose that even within these lava oceans, extreme life could persist. You can imagine creatures that subsist on the minerals and gases released from the planet's surface, establishing entirely unique ecosystems. Nature's capacity for invention is truly staggering, and the prospect of life evolving in these extreme settings is deeply compelling. The strange orbits of certain exoplanets also present some fascinating puzzles. Worlds like HD 80606b experience drastic climatic cycles because of their highly elliptical paths around their star. Try to imagine a place where the temperature fluctuates so wildly that you could go from a temperate climate to an ice age within a single year. In such a volatile scenario, life would need to evolve extraordinary survival strategies, perhaps entering a dormant state during the most brutal phases of the cycle, awaiting more temperate conditions to return. The concept of water-based exoplanets is equally captivating. A planet like GJ1214b, for instance, might possess oceans of lava, or even water in a supercritical state, a phase between liquid and gas. Life could potentially adapt to these exotic oceans, drawing on the mineral and chemical resources within them. Just think of creatures more alien than anything on Earth, navigating these incredibly hot waters, and possibly communicating through shifting colors or patterns of light. We also have to consider the diamond worlds, like 55 Cancri E, where carbon is the fundamental building block. In a setting where carbon exists in forms we've never encountered, could life emerge with a biology based on this element in completely new ways? The biochemistry on such a planet might fundamentally challenge our conventional understanding of what it even means to be alive. Then there are the dancing planets, like those found in the TRAPPIST-1 system, which present a completely different kind of dynamic. With several planets locked in orbital resonance, their gravitational push and pull can generate unique conditions on each world. These constant interactions could shape the planet's climates, potentially fostering environments suitable for life. On one of these worlds, gravitational tides might even drive seasonal changes, allowing life to thrive in ways we are yet to conceive. With rogue planets, which drift through space without orbiting a star, the question of life becomes even more profound. How could anything survive in total darkness and extreme cold? One possibility is that these worlds have a geologically active core that generates enough heat to sustain liquid oceans beneath a frozen surface. Such a refuge could support life forms that are entirely independent of sunlight for their existence. As we investigate exoplanets with peculiar atmospheric conditions, like HD 209458b, we face the possibility that their atmospheric chemistry could be a cradle for life. The specific combinations of gases and pressures that seem lethal to us might actually be the perfect environment for organisms that have evolved within them. This forces us to expand our definition of what a habitable atmosphere could be. Super-Earths, such as LHS 1140b, offer yet another compelling scenario. These worlds, which are sized between Earth and the gas giants, might have the right characteristics to support liquid water, an element crucial for life as we know it. But what other kinds of life could arise in a place where the gravity is stronger and the planet's makeup is so different from our own? Finally, we shouldn't overlook the impact of extreme seasons, which some exoplanets experience due to a significant axial tilt. This could create an environment where life adapts to vastly different cycles, perhaps developing unique reproductive strategies that are perfectly timed to the dramatic seasonal shifts. Each of these so-called impossible exoplanets compels us to rethink everything we know about life, reminding us that in the vastness of space, the possibilities are truly endless. Ultimately, the question isn't merely whether life exists on other planets, but rather what astonishing forms it might take in the most extraordinary conditions imaginable. By exploring these possibilities, you open your mind to the idea that, in our immense universe, what appears impossible might just be a matter of perspective. So, how do we locate these distant worlds that seem to have been pulled directly from a science fiction novel? The search for these impossible exoplanets is akin to a thrilling cosmic treasure hunt. However, instead of a weathered map, astronomers employ a suite of sophisticated tools and groundbreaking techniques to uncover these strange and mesmerizing worlds. This pursuit requires both incredible precision and a touch of creative thinking to find what's hidden in the deep expanse of space. One of the most widely used techniques is known as the transit method. Picture a distant lighthouse. When a ship sails past it, the light momentarily dims. In a similar way, when an exoplanet crosses in front of its star from our point of view, it blocks a tiny fraction of the starlight. By observing and measuring this slight dip in the star's brightness, astronomers can determine the planet's size and how far it orbits from its star. It's like listening to a grand symphony and noticing a single instrument fall silent for just a moment. Another compelling technique is known as gravitational microlensing, where nature itself provides the essential tool. Imagine how light bends as it passes through a drop of water. In a similar fashion, when one star transits in front of a more distant one, the gravity of the closer star acts as a lens. This phenomenon magnifies the light from the background star, allowing astronomers to spot planets that would otherwise remain completely undetectable, giving them a remarkable ability to see what is hidden. Beyond these approaches, there are more intricate methods like spectroscopy, which involves analyzing the light that a planet emits or reflects. This process separates the light into a spectrum of colors, much like a rainbow, where every chemical element possesses its own unique signature. If an exoplanet's atmosphere contains significant amounts of oxygen or methane, scientists can detect these telltale signals, as if they are intercepting and decoding messages sent from across the cosmos. Think of it this way. Each time we study an exoplanet, we are essentially cosmic detectives examining a scene, searching for clues that might reveal its true nature. So, what specific evidence are we looking for? The characteristics that signal a world might be interesting, or even habitable, are both varied and fascinating. A planet's distance from its star, its size, and its chemical makeup are just a few of the primary keys to understanding what it's really like. The search for exoplanets has captivated our collective imagination, leading to a dramatic surge in research over the last few decades. Equipped with increasingly sophisticated telescopes and dedicated space missions, such as the Kepler Space Telescope and its successor, the Transiting Exoplanet Survey Satellite, or TESS, scientists have successfully identified thousands of these distant worlds. Every new confirmation is another leap forward in our comprehension of the universe's diversity.
These discovery methods not only allow us to locate planets in stable orbits around stars similar to our own sun, but they also help us find worlds that orbit more exotic stars, or even seem to defy our current understanding of physics. Human curiosity is boundless, and it seems that each discovery only sparks more profound and intriguing questions that demand answers.
The work is far from over once an exoplanet has been confirmed. The research continues as scientists meticulously analyze data, seek out patterns, and strive to understand the behavior of these alien worlds. In this way, the study of exoplanets resembles a grand cosmic puzzle that is slowly being pieced together, with each new addition providing us with a more complete vision of what the universe holds.
As astronomers continually refine their instruments and methods, they are also pioneering entirely new techniques. The hunt for seemingly impossible exoplanets is a field in constant flux, where innovation is highly valued and international collaboration is indispensable. Modern science is powered by these synergies, enabling researchers from across the globe to unite toward a common goal: to better comprehend our place in the cosmos. But what would happen if we found an exoplanet that appeared to have all the necessary conditions for life? The answer could fundamentally reshape our perception of the universe and of ourselves. The possibility that other intelligent beings exist somewhere in the void is one of the most powerful motivations driving this search, and each discovery inches us closer to answering that monumental question. Are we alone? The search for impossible exoplanets is not merely a hunt for habitable real estate, but an exploration of nature's boundless creativity. Every new world we find provides a glimpse into a corner of the universe we could never have imagined, helping us understand how planets form, how they evolve, and ultimately, how life might take hold in the most extreme conditions imaginable. These exploratory methods are not just exciting from a scientific standpoint. They also teach us a great deal about ourselves, forcing us to confront our own limits and our deepest aspirations. Each new finding is a reminder that despite all we have learned, the universe still guards countless secrets. The quest for exoplanets is a thrilling journey that has only just begun, and the greatest discoveries surely lie ahead. So-called impossible exoplanets represent a true cosmic puzzle that invites you to reflect on the immense diversity of the universe. What can these strange worlds teach us about existence, and why are they so crucial in our search for life? It's worth contemplating the profound implications of these planets that consistently challenge our understanding of what is possible. Every time a new exoplanet is discovered, it is like opening a window to a reality that we could have only dreamed of. These worlds, which often seem as if they were lifted directly from science fiction, offer us a unique view into how planets can form and persist in the most extreme environments. Could a planet of molten lava possibly host life? The answer may be far more complicated than you think. By investigating such extreme conditions, we also expand our definition of what might be considered a habitable environment. The existence of exoplanets with highly unusual atmospheres, like HD 209458b, forces us to question our own preconceived notions about physics and chemistry. What if life could evolve in an atmosphere filled with elements we consider toxic? What seems inhospitable to us might be the perfect home for entirely different life forms. Exoplanets that orbit binary star systems, like Kepler 16b, provide another fascinating example of this. These worlds experience climates and geological forces that are radically different from anything we know on Earth. How does the presence of two suns influence a planet's life cycle? The answer could reveal new dynamics in planetary formation that we do not yet fully comprehend. Investigating rogue planets, those worlds that drift untethered through the galaxy, compels you to contemplate their history and the circumstances that left them so isolated. It's possible these planets are the final remnants of disintegrated star systems, or perhaps they were ejected by powerful cosmic collisions. Every discovery offers fresh insight into the deep past of our universe. Exoplanets with severe seasons demonstrate that climate can be far more varied than you might imagine. A planet with a pronounced axial tilt could undergo immense climatic shifts, which would in turn influence its potential to harbor life. This raises the question of how life could possibly adapt to a world that flips from a frozen winter to a blazing summer in a very short time. Another vital consideration is stellar radiation, which directly shapes the atmospheres of exoplanets. Worlds like HD 189733b serve as a clear example of how close proximity to a star can fundamentally transform a planet's conditions. These inquiries present a vast array of possibilities that compel you to think beyond the conventional, even asking if a radiation-soaked atmosphere could nurture extreme forms of life. Super-Earths, which are planets larger than our own but smaller than gas giants, are also a central focus of this exploration. The implications of their size for habitability are profound. For instance, their stronger gravity might support dense atmospheres capable of sustaining life in forms you have yet to conceive. In many ways, these super-Earths represent an ideal setting for investigating how life could evolve under completely different physical constraints. When you analyze these extraordinary worlds, you begin to grasp that the universe's variety is not confined to what is already known. Each new finding challenges us to redefine the boundaries of both life and planetary formation. It's a constant reminder that science is not a fixed body of knowledge, but a process that advances with every discovery, unlocking new possibilities and questioning established certainties. The search for these unusual exoplanets also has a profound effect on your grasp of the cosmos itself. By examining these worlds, scientists are not only looking for answers about life, but are also decoding the formation history of our own solar system. Every exoplanet identified represents another piece in the vast cosmic puzzle, helping you to better comprehend our own place within it. Ultimately, it's crucial to acknowledge that the hunt for exoplanets is more than just a scientific endeavor. This exploration carries significant philosophical and ethical weight. As you push the frontiers of knowledge, you must also reflect on how the discovery of extraterrestrial life could alter our view of humanity and our purpose in the universe. In the end, these seemingly impossible exoplanets stand as a monument to the inventiveness of nature and to our own capacity to probe the unknown. They show you that environments appearing inhospitable could in fact be home to incredible life forms. Each new discovery moves you a little closer to deciphering the immense and enigmatic tapestry of our cosmos, inviting you to dream, to investigate, and to persistently seek answers in the limitless expanse. The exploration of exoplanets has launched a new era in your comprehension of the universe. When you look up at the night sky now, you see more than just twinkling lights. You can envision distant worlds, each with a unique history and character. What truths might these incredible planets reveal about our own existence? The answer could be more thrilling than you anticipate. This journey has revealed that the diversity among exoplanets is truly staggering. From infernal worlds of molten gas to frigid, ice-covered spheres, each one challenges your established ideas about habitability. The explanation for such extreme conditions lies in the intricate processes of planet formation and the profound influence of their stars, creating a kaleidoscope of scenarios where life might find a foothold. Picture a planet where rivers of lava flow freely and the atmosphere is thick with toxic gases. While it sounds like science fiction, such worlds are a reality. But could life be found in a place like this? Is it possible for biology to adapt to conditions that seem utterly alien or even impossible to you? It suggests that life as you know it is just one of many potential expressions in the cosmos. The study of exoplanets also makes you consider the impact of their atmospheres, some of which are so peculiar they seem to violate all known principles. What would it mean if a planet with conditions entirely different from Earth's were to host living organisms? It opens the possibility that life is not exclusively born from gentle environments, but can flourish in the most unexpected corners of the universe, where chemistry operates by different rules. Seasons on these distant worlds can be incredibly harsh, which in turn affects their climate and geology. Can you envision life on a planet where the seasons shift dramatically over just a few days? In such an environment, adaptation would be the absolute key to survival. These planets might be teaching you about the sheer resilience of life, demonstrating that the struggle to exist can unfold even in the most hostile of settings. The interplay between multiple moons can reshape a planet's geology, sculpting landscapes you could never have imagined. Gravitational forces become a defining factor in such a complex system. How might your perception of life change if an exoplanet had several moons, each influencing its climate and conditions? The intricacy of these systems poses compelling questions about how life might evolve within interconnected ecosystems. The quest for exoplanets is far more than an intellectual exercise. It has deep ramifications for both science and philosophy. What does it mean to be human in a universe teeming with such radically different worlds? In pursuing these answers, you are also exploring your own identity. Every finding brings you closer to understanding your place in the cosmos, a journey that everyone can share. The very tools you and I use to locate these distant worlds are perpetually being refined. From powerful telescopes that pierce our planet's atmosphere to ingenious new approaches like gravitational microlensing. I find that every single one of these advancements inches us closer to the underlying reality of the cosmos. Yet our human inquisitiveness is boundless, and each answer we uncover only seems to generate a fresh wave of questions. When you reflect on the sheer variety of exoplanets, it becomes clear that this quest is fueled by more than just scientific ambition. There's a profound emotional component that compels us to venture into the unknown. I believe this fascination with the universe is a common thread uniting all of humanity, a shared desire to comprehend what exists beyond the world we call home. Every discovery serves as a powerful reminder that you and I are part of something immeasurably vast. The implications of these seemingly impossible worlds are truly enormous, teaching us about the incredible diversity of planetary formation and the countless ways life might potentially arise. Each newly identified exoplanet offers you a lesson in nature's sheer flexibility and its remarkable capacity for adaptation. It makes me wonder what other astonishing finds await us as we persist in our search through the cosmos. Exploring these alien planets also invites a period of self-reflection about our own obligations as residents of Earth. What lessons can you and I learn from these other worlds to become better custodians of our own? The hostile conditions on many of these planets act as a kind of mirror, showing us the challenges we face and reminding us just how delicate our own environment truly is. I think the significance of studying these incredible exoplanets extends far beyond simple curiosity, as it presents us with an opportunity to broaden our entire understanding of life, chemistry, and the complex dynamics of star systems. With every new find, the boundaries of what you might consider possible are pushed further outward, transforming what was once pure imagination into a legitimate field of scientific inquiry. It truly makes you appreciate the limits of our knowledge and encourages us to dream on a grander scale. Ultimately,
When you look up at the night sky and contemplate the diversity of known exoplanets, you realize the universe is brimming with surprises. This knowledge inspires us to continue our exploration, to never stop asking questions, and to persist in our search for answers. The grand adventure of discovering the unknown is a journey without an end, and every step you and I take brings us nearer to unraveling the great mysteries of existence.